Hi there, myself Madhav Jha. I welcome you to CodeChef and let's have a look at this question.
The problem is chef and string. The problem difficulty is easy and there are no prerequisites. Let's have a read at the problem. Chef has recently joined Exxon and as a member of We Not I Legacy, so he wants to apply this motto to a string he receives on his birthday. Now chef string denoted A is very large, so you are instead given a smaller string S of length n and a positive integer k. That means chef string is then represented as string A k times. That is, the smaller string that we are given, let's note it as A, is going to be multiplied k times. So we'll keep on adding it to its right k times and we'll get the original string. Now, for example, if our S happens to be EXUN and k is 3, then we concatenate it thrice and get the original string. That is, the original length is n multiplied by k. Now, as a sign of respect for his club, Chef refuses to have the letter I present in the string. So, Chef will replace every occurrence of I in his string with any other upper English letter of his choice. Note that different occurrences of I may be replaced with different characters. For example, in this example I, the first I can be replaced by, let's say, B, and the second I can again be replaced with anything. It could be B, C, D, Z, anything that we want. Now, Chef defines the score of a string to be the number of adjacent characters that are equal. Formally, the score of A equals to the number of indices I such that AI is equal to AI plus 1, and this has to happen on the original string of length n into k. Now our task is to find out the maximum possible score that chef string can attain after replacing every occurrence of I with some other letter. So for input format, for each test case we are given two lines. The first line will contain the integer n and k, and the second line will have the smaller string s of length n. For the output format, we simply have to output the maximum possible score of A. As for constraints, number of test cases will go from 1 to 2 into 10 raised to 5. Value of n will go from 1 to 5 into 10 raised to 5. And the value of k will go from 1 to 10 raised to 9. From this itself, we can understand that making the original string of length n into k and then finding the solution is going to be very difficult because the string is going to be very large. So in our approach, we'll find out how we can do this by just performing operation on the smaller string of length n. Let's see the sample inputs. For the first sample input, the smaller string length n is given as 3 and value of k is given as 2, and our smaller string is I. Let's say we replace the i's with a. So this becomes triple A. And if we were to concatenate it twice, this is what we have. So the number of the score, that will be the number of adjacent indexes that are equal. So it will be 1, 2, 3, 4, and 5. And as you can see, that's the answer here. Let's see how we can approach the solution. So since we know that we have this smaller string s of length n, since this is going to be duplicated, what we can do is we can simply find the score that will be of this smaller string and then simply multiply it by k. Why? Because whichever combination of adjacent that is appearing here will also appear in all the other k strings, right? All the other ones that we are going to concatenate here. So the whatever score that we find here can simply multiply it by k and we'll get our answer. But is it that easy? Let's go through it. So any I that we are having, what we can do is we can replace it with its next, that is the right or left element. So in this case, what we have done is for this I, we have replaced it with the right element, right? And for this one, we have replaced it with the left element, making it A. But if you see here, the first and last character here are equal. So what happens? For this individual string, nothing much happens. The score remains 2, right? This is 1 and this is 2. But what happens if we end up concatenating something? Now if we do that, Again, the score for this individually is 2. But if we see the connection, that is the last and first are equal, this gives us an additional score. But this additional score will not be present for all k. It will only be present for k minus 1. So what we can do is, we can go from left to right and find i's and replace them with the left character that is not I. Similarly, we can go from right to left and again replace any remaining I character to its right character. Once that is done, we can keep and start finding the scores. Any score that we find, we can add it k times because it will be present everywhere in all the strings that we are going to concatenate. Now once this is done, at the end we'll check if the first and last character are same. If that is the case, we'll additionally add k minus 1 to our score, and this will give us the maximum score that we can get, and this will be our solution. Let's see how we can implement the solution in C++. So for each test case, we call the function solve. In solve, we take the input of n and k, then we take the input of our string. Then we find whether there exists a non-I character. Why do we find this? Because if all the characters are I, it means we can simply replace them with anything that we want. And we know the score for sure. It is nothing but n into k minus 1. Why? Because if everything is equal, we can get all the n adjacent to be equal. So for that reason, this is what we are going to print. But if that is not the case, what we'll do is, whichever is the non-I character that we have found, after it we'll start finding whichever is the ith character, whichever character is I, and replace it to its left non-I character. We do this again from right to left to make sure that all the i's are replaced greedily. Once this is done, go over each index and check whether it is equal to its next index, that is, it is equal to its adjacent. If that is the case, we add k to our score. Why do we add k? Because this smaller string is going to be multiplied k times. So if a pair exists in 1, it is going to be existing in all k. That's why we increment the score by k. At the end, we find if the first and last character are equal. If that is the case, k minus 1 times we are going to find this adjacent indices. So for that reason, we increment our score by k minus 1. At the end, we print this score, and this is the maximum score that we can get. And as you can see, I've got an AC in my Python implementation. Let's see how we can implement this in Python. Again, for each test case, we call the function solve. We take the input of n, k, and then we take the input of our string. We convert the string into a list so that it is easier to manipulate. Then we find the index of the character that is not I. If it does not exist, it means our answer is nothing but n into k minus 1. But if that is not the case and it does exist, first we'll go from left to right and then from right to left and change the character I whether to its nearest left non-I character or to its nearest right non-I character. Once all this replacement is done, we start finding the pairs of indices that are adjacent and equal. For each pair that we find, we increment our score by k. At the end, we check if the first and last character are also same. If that is the case, we increment our score by k minus 1. At the end, we print this score, and as you can see, I've got an AC in my Python implementation as well. So I hope you understood the problem, the approach, and how we can implement the solution in both C++ and Python. Have a very good day, and I'll see you in the next video.